Okay, so in this video, we're briefly, here, let me go back a page. We're briefly going to discuss how two variable linear equations work, right? So, should get specific there. So, two variable linear equations, right? We're not going to get into anything nonlinear just yet. So, for the sake of keeping the video short, we're just going to look at this example, right? So, if you want, go ahead and take a second to read this. You can hit pause and read this problem on your own if you want. Okay, so otherwise, I'm going to go ahead and get started here on number one. So, number one is asking us to make a table that shows how many accidents A, Jeffrey will have in D days, going from 0 days to 28 days, right? So, on this next page here, we have a table that we can use, and we can go ahead and say that um, accidents goes here and days would go here. This is equivalent to saying, that this is X, this is our Y column, right? And the reason being, right, is that X is our independent, right? And Y is our dependent. Okay, so how does that relate to days versus accidents? So, what it comes down to, most simply, is that the number of accidents depends, right, on the number of days here. It would be ridiculous to say it the other way around, right? So, that said, we're told about how every week he has two accidents. So that means we can pretty much just count in sevens, right? So in 7 days, how many accidents will Jumpy Jeffrey have? Well, he'll have, and actually it says from 0 to 28 days. So we're going to start with, and let me use a darker blue here. We're going to start with 0 days. So in 0 days, we're told that he already has three accidents, right? If we refer back to here, he already had three accidents. Okay, and then in a week, he'll have had two more accidents. So we just add two. Of course, he's going to have had five, and the pattern would just continue 7, 9, 11, 13, 15, and so on, right? And I don't even think I need to go that far because it says to go. So 1 week, right, would be plus 2. 2 weeks would be 14 days, so plus 4. This would be 21 days, or 3 weeks, 28 days. So this is really where we just needed to stop. Okay, so that would be our table. That would be our answer for number one. Number two, true or false? The number of days that have gone by depends on the number of accidents. Well, we already established that. It's obviously false. Okay, the number of days that have gone by, it's ridiculous to think that time would depend on the number of accidents that Jeffrey had. That would be like saying, well, Jeffrey didn't have any accidents today, so time is standing still, which is beyond insane, right? Uh, on to number three. What does this tell you about the relationship between time passed and the number of Jeffrey near deaths, quote unquote, right? So as time goes on, right, as time continues on, right, accidents increase. He's just insane. As time goes on, he's going to keep doing his crazy stunts, and he's going to continue to have more and more accidents over time. Okay, so next part of our example, if we're free to assume that Jeffrey never spends much time in the hospital, no matter what kind of accident that he has, what is the rate at which Jeffrey has accidents? Right, so there's two ways to look at this. There's the purely mathematical way to look at it, right? We know, so if it's a rate or a rate of change, we know this is a slope. And slope is equal to the change in the dependent variable with respect to the change in the independent variable, or delta y over delta x, or rise over run. right? And the change in y is expressible arithmetically like so. The change in x similarly is expressible like that. Okay, so if we use this simple formula mathematically, so we say that this is x1, y1, and x2, y2, right? We simply have 3 minus 5 over 0 minus 7, and this gives us negative 2 over negative 7, or just positive 2 over 7, which basically means, if we're referring back to this, we would say delta accidents with respect to the number of days that have gone by, and we arrive at 2 accidents for every 7 days, or 2 accidents per week. And that brings us to the other way that we could have approached this, right? Our rate, quite simply, if we just use common sense, every week he has 2 accidents. So that means 2 accidents, right, per 7 days. Okay, so slope is pretty cool like that. It is just simply a rate. So here I'm simply going to say m is equal to 2/7, right? Number 2 is asking us in slope-intercept form, write a linear equation or function. We're gonna look at this as a function, right? Because we need to get used to seeing it that way, and not so much as y equals mx plus b. We need to see it as f of x equals mx plus b. And if you don't remember, right, y is a function of x because, right, y depends, it depends on x. Okay, so we say it is therefore a function of x. So what we would say is the number of accidents is a function of the days that have gone by, right? So, and let me use a different color here. Let me try to color code, just doing everything in green. That's going to make some people go cross-eyed, I think. Okay, so we're going to say accidents is a function of days, right? We know the rate of change. Again, we're doing f of x equals mx plus b. Okay, so we know m, right? It's right here. So our rate of change is 2/7, right? Times x. So that's our dependent variable, so the number of days. But what is our y-intercept, right? Well, common sense tells us the y-intercept occurs where? Well, it occurs at the y-axis. And where is the y-axis if not at x equals 0, right? So when x is 0, what is y? Well, y is 3 when x is 0. Therefore, our y-intercept must be 3, and that's a positive 3. So we say plus 3, right? So then on to number 3, using your graph boards, right? And of course, you probably don't have a graph board at home, but if you have graph paper or something, graph your function or equation that you got back here from number 2. Okay, so we're going to graph this guy. Okay, and if you were going to do that on paper, let's see if I can insert a blank graph for us here. Yeah, I should have been more prepared, but seems like a good idea to just go ahead and show you how you would do it by hand, because that's probably what you're doing at home. So I've got a blank graph here. Don't have a whole lot of room, but that's okay. So if you remember from geometry or algebra 1 or wherever you first learned how to do this, I always start with the y-intercept, right? So again, one more time, we have a of d is equal to 2/7 times the number of days plus the 3 accidents that already have happened, right? And we're not going to call this f of x. We're going to call this axis a of d axis. And this x-axis, right, we're going to call this the days axis or the d axis. Okay, anyway, so there's our y-intercept. This is our function we're trying to graph here, right? So if we want to do this, we're simply going to use rise over run, right? So our change in y over our change in x, or in this case, our change in accidents with respect to the change in days, and that is simply 2/7. So 1, 2, and we're going to count over 1, 2, 3, 4, 5, 6, 7. So that would be where our next point is, and then we can just kind of mirror that by going 1, 2, right, and then 1, 2, 3, 4, 5, 6, 7 out to over here. right? And then we know we can just continue. So 2 by another 7, I know I'll just end up at 14. And minus 2 minus 7, I'll end up at negative 14. And then we can connect with just a nice straight line. And let's see if my tablet is going to let me do that. Oh, cool. That's not helpful at all. Actually, yeah, it is. I'm just stupid. It is going to be difficult using my little crappy stylus. Well, I say it's crappy, but it's working well enough, isn't it? Okay, so I can go ahead and right click. Really? Bro. Okay, so I guess I can't right click on this, but I'll go ahead and trace out the line. If you can't see it very well on your screen, it's not letting me draw now. So here's our line here, and this line would be representative of this linear function. Okay, so there you have it. That's how you graph two variable linear equations. Goodbye.